the second step is to earth the gold leaf. Please listen attentively. And I told you in earthing the gold leaf is to connect a wire from the gold leaf to the ground. That is earth. And once that is done, these electrons will flow to the ground. The electrons will flow to the ground. Now, once the electron, all of them, has migrated to the ground, the leaf will collapse, indicating absence of charges. The leaf will collapse, indicating absence of charges. Because all the electrons, they have gradually moved to the earth. You know, the earth is an ocean of charges. The earth. That's why it's very, very important if you are going close to on Monday, I called one stupid house man that said he knew how to connect one or two things. And he charged so much money, I said you should start. I don't know what happened. He wanted to use his teeth to join one of the wires. And instantly, they brought the light. So he was shouting my name, but there's nothing I can do. I know if I touch him now, I will still be in the same mood with him. So after a while, I don't know what happened. He fell on the ground. Jegoteli milk. Near a bongo. Bye bye. I didn't pay him because I wanted home. So when you go close to electricity, you have to be very, very careful. You know, when Faraday told those scientists that the current that is passing through this wire is strong enough that it can kill people, they said it's a lie. Yes, that is exactly what happened. When he connected it, he told them that the current, the voltage is so high that it can electrocute them. Some of them say it's a lie. They went and touched it. It killed them. It killed about 4 of the scientists. They want to prove him wrong. And from there, they believe what he was saying. So the third step, please listen attentively. The third step is why the charging body is still intact. You remove the earth. The first is to remove the earth. Do you know why you first of all remove the earth? You saw what happened now? Please listen. The third and the last step, you remove the earth. Do you know why you first remove the earth? Because if you remove the charging body, this will flow down, electron will migrate from the ground and neutralize it. Then all the effort is wasted. So the first thing you do is to remove the earth first. Remove the earth. After you have removed the earth, you remove the charging body. Now, once you have removed the charging body, the proton will flow down, and this way diverge, indicating the presence of charges. So the first thing is to remove the earth. First thing you do is remove the earth. After removing the earth, you remove the charging body, and once you have done that, the leaf will diverge, indicating the presence of a charge. Now you have charged the gold leaf positively. You have charged the gold leaf positively. The third one is remove the earth. Remove the charging body. Then the leaf diverges, indicating the presence of charge. Now you have charged the gold leaf positively. Our sister here presented a question. He said, "Uncle, please, non-conductors are poor conductors of electricity, except graphite." She said, "Uncle, does it mean that graphite can be called a semiconductor?" So she was asking. She said that, "Uncle, please, non-conductors are poor conductors of electricity." That one is correct. Now she said again, "Accept graphite." Graphite, is it a conductor, a non-conductor? So why are you saying, you wrote it as if it is a non-conductor? From the question, we were very confused. You said, "Uncle, non-conductors are poor conductors of electricity, except graphite." That means you are including graphite as a non-conductor. Do you understand what I'm saying? But graphite, is graphite a non-conductor? Chemistry student, we have two crystalline allotropes of carbon. Is that also? One is diamond, and the other one is what? And diamond is the hardest substance known in the world, and because of the shape, it could not conduct electricity. Is that also? But in this lattice structure of a graphite, we still have one electron that moves around like an idiot. In the lattice structure of a graphite, we still have one single electron, and that electron can move around, and that's why a graphite is a conductor of electricity. Please say, is graphite, can graphite be called a semiconductor? Graphite is not a semiconductor. The person who's supposed to ask this question is your chemistry teacher. All right. Now we have three methods of charging a body. The first one is by friction. The second is contact method. The third one is by induction. You can call it electrostatic induction. If you don't want to use the word induction, you can use the word electrostatic induction. In friction, materials are rubbed between each other. In friction, materials are rubbed between each other. Example, in the production of positive and negative charges, we say that we rub a glass rod with 6 and we rub ebonite rod with 4. I said in friction, materials are rubbed between each other. And I give you an example. Example is in the production of the positive and the negative charges. I said in the production of the positive charges, a glass rod is rubbed with silk. Why in the production of negative charges, an ebonite rod is rubbed with fur. Now, very, very important, in friction, two different charges are produced. The materials will have different charges. So if I'm rubbing this material, this one with this one, at the end, two of them will have different charges. If this one will have positive charge, this one will have negative charge. That's what we are saying. Do you understand what I said now? If these two materials, A and B, if I rub them now, at the end of the day, this one will have another charge, this one will have another charge. You understand? In contact is by bringing the body in contact with each other. You don't need to rub it. You don't need to rub it. You just need to bring it in contact with each other. Now, in charging of a gold leaf electroscope, we use the contact method. In charging of a gold leaf electroscope, we use the contact method. Hope your minds are here. Those at the back. In charging of the gold leaf electroscope, we use the contact method. Now, we have induction. In charging of the gold leaf electroscope, we use the contact method. Now we have induction. Electrostatic induction is defined as a method of charging a body by men bringing a charged body near the body. A method of charging a body by men bringing a charged body near the body.